Welcome to Ivy-GreGMAT GMAT Quant Intro Session, Coordinate Geometry. I am Arijit. Let's start. Coordinate geometry. Coordinate geometry or Cartesian geometry is the study of geometry using a coordinate system and using principles of algebra. We'll learn how it is related to algebra also. Okay, so what do you mean by this coordinate system? Coordinate geometry reminds us of a graph paper having some coordinates drawn on it already. So this graph paper or this plane is called as a coordinate plane, as we are seeing it here. A coordinate plane. This one. This is a coordinate plane. So coordinate plane is a two-dimensional surface in which you can plot points, lines, and curves. In coordinate geometry, points are placed on a coordinate plane like this, or any point here, 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 and we can draw a line using these, and this is called as coordinate geometry. One definite thing about this coordinate plane is that there are two scales, x-axis and the y-axis. They are called as the x-axis and the y-axis, and they are perpendicular or at right angle to each other, and they meet at a point which is called as the origin. Clean. So a bit of it on further on this. What is an x-axis? What is a y-axis? X-axis is the horizontal scale. This is the x-axis. The horizontal scale. The values here are positive on the x-axis and here are negative on the y-axis. We can see they are all negatives. The y-axis is the vertical scale. This is the horizontal scale and this is the vertical scale. On the vertical scale, the values here are positive on the y-axis and the values here are negative. This point is called the point of origin because both x and y-axis meet at a point of origin which is 0 and 0. We will be using this time and again, so that's the reason I'm trying to go from the very basics. What are quadrants? Whenever I draw a line like this on any plane, it divides into four parts: 1, 2, 3, and 4. And these four parts are called as quadrants. So first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. Now, if I put a point, it cannot be 1, 2, 3, 4. It has to take into consideration both x and the y axis. So it is written in the form of x and y, and this is called as an ordered pair. That is it. The sign in the coordinate geometry of the coordinate is important. A positive number must go on the right side of x-axis and up on the y-axis. A negative number means it is on the left of x and down of y. That much. Let's understand a bit of it further. Let's draw it here. Say we have an x-axis and a y-axis. We have got a 0 here, followed by 1, 2, 3, 4, 5, etc. And the ones in the top are positive. So again, 1, 2, 3, 4, etc. One in the bottom are -2, -3, etc. And the ones on the left are also negative. So -1, -2, -3, -4. It's not on the scale. So, but this is for our understanding. We have understood that the first quadrant, second quadrant, third quadrant, and this is the fourth quadrant, the four parts. Fair? All points here, any point here, will have x more than 0 and y more than 0. Any point on this side will have x less than 0 and y more than 0. In the third quadrant, it will be x less than 0, y also less than 0. On the fourth quadrant, it will be x more than 0, y less than 0. This is very important. The ordered pair are x and y. We must remember the sign of this x and y. Then only we can plot a point here. Now, once we are done with plotting a point, uh, a very simple question can be, what is the distance between 2 points? So, let's take an example, or rather, let's take an x and y. There are two x's and y's. So, if I say there's a xy here, and there's a xy here. So, this is x1, y1, this is x2 and y2. The distance between these 2 points will be, so d is equal to rooted over x2 minus x1 the whole square plus y2 minus y1 the whole square. If it originates from here to some point x and y, the distance will be d will be root over x square plus y square. We'll further delve into it just to catch up with something. So the distance between any 2 points is given by the formula x2 minus x1 the whole square plus y2 minus y1 the whole square. If it comes from the origin, rooted over x square plus y square. Now you can very well ask me, if there are 2 points x and y, xy, sorry, one second, let me rub it. And this is x2, y2. Where this is the distance d. You can say, what is the midpoint? So we came out with something called as the midpoint theorem, where midpoint, or m, is equal to, say m is defined by a coordinate. Obviously this will be, say this is xm and ym. So midpoint xm, ym for this x1, y1 and x2, y2 will be, xm will be x1 plus x2 divided by 2, and ym will be y1 plus y2 divided by 2. Simple. So now we know how to calculate the distance, because it is not a straight line. We will have to take the coordinate into consideration and the midpoints. Fair? Let's move. Just to round up our learning, the distance between the given coordinates 2 points are this and this. So the distance will be x2 minus x1 the whole square plus y2 minus y1 the whole square rooted over. The distance between the point A and the origin is this. D is equal to root over x square plus y square. So the midpoint of a line segment is defined by xm is equal to x1 plus x2 by 2 and ym is equal to y1 plus y2 by 2. Three formulas or three simple understandings. So now we know how to plot a point, where on a coordinate it will be positive and negative, and how to calculate the distance between these 2 points, how to put a point right in the middle and see where is xm and where is ym, or rather, where is the midpoint between the in a line segment. Clean? So let's see how these lines are related to linear equation. So in a coordinate geometry, the lines in a Cartesian plane can be described algebraically by linear equations and linear functions. So what we are talking about? It is saying that a line is not a random line. It has been drawn keeping in mind the equation of a straight line. So in a general form, this will be, if I put it on a general form, to define the line, it is ax plus by plus c is equal to 0. This is a general form for an equation of line where the slope is etc etc. We'll come to this. And the point intercept form is y is equal to mx plus b. So let's do a bit of an understanding here. What is the equation of a line? Straight line. As we just saw, it is ax plus by plus c is equal to 0. Clean? Which implies that this is the first form, which is the general form of writing what is a straight line like. Which implies that if I put by here is equal to minus ax plus sorry my minus c, which implies that y is equal to, I'm just changing the same equation, is equal to minus a by bx minus c by b. Now the moment I write this, I am putting it in the form of something called as the point intercept form or the slope intercept form. This is the why this, because the moment I write it like this, I can, looking at the equation, I can make out how the line looks like on a coordinate plane. For our convenience sake, we have generated something where y is equal to mx plus b, because this one or this m is called as the slope. This part is called as the y intercept, or rather where the line touches y. So this c by b, or in our form mx plus b, b is the place where the line crosses the y-axis. Let's do a bit of more understanding here. So we know what the slope is looking like. We know what the now it becomes clear. This m is the slope of the line. So m is equal to the slope of the line. This tells us how steep is the line. So in a coordinate system, the line can be like this, the line can be like this to the x-axis. This m, the value of this m, positive, negative, etc., says how steep is the line. This b This B is called as the y-intercept, or where the line crosses the y-axis. Clear? So we came out with two equations, one in a general form, other in this form. So whatever line we are drawing can be put in an algebraic form and vice versa. So if I've got a straight line equation, I can put it in a form where I can understand how the slope looks like, etc. So the slope of a line, let's quickly recapitulate whatever we have learned, is the gradient of the line describes the steepness or the incline or the grade. So as we are seeing that the slope is actually saying how inclined it is. The higher the slope indicates a steeper line. Now we'll come to this rise and run later on. Rather, let's now focus here, given the 2 points. The slope of the line is m is equal to y2 minus y1 by x2 minus x1. If the equation is given in a point intercept form, it looks like this, which we learned y is equal to mx plus b. If the equation is given in a general form, it is ax plus by plus c is equal to 0, where the slope is, as we saw it, m is equal to minus a by b. The y-intercept is minus c by b. The same thing, whatever we learned, we revised the same. Now the slope and its direction. Obviously, as we saw that it will show us the steepness, etc., etc. Let's see. Slope of the line is m. If it is more than 0, then if m is more than 0, the slope will be called as positive slope. How? Say the slope is like this. This is a positive slope. Fair? If the slope is like this, that means m is less than 0. So it is a negative slope. The third option can be uh, say m is more than 1. Then it's a steeper slope like this. Let's say it's a steep slope. It can be a fourth type. Let's see how it is. Say y is equal to m and x is 0 plus b, then y will become equal to b. If x is 0, then y becomes equal to b. Then m is equal to 0. If that is the case, the slope will be like this, where m is equal to 0. If it's a vertical line, then m is undefined. They're the basic 4 types. So we will delve into the questions in the later half when we are doing the sessions. We'll actually be able to. This is just the basic understanding. So let's revise whatever we have learned. A positive slope y increases as x increases. As x is increasing, y is also increasing. So it is a positive slope. So the line slopes upward to the right. Upward. The slope will be a positive number. Rather, m will be more than 0. A negative slope, y decreases as x increases. X is increasing. This is going up. But y is decreasing. So it is a negative slope. The, the line slopes downward to the right. X is increasing, but y is decreasing. The slope will be a negative number. So m will be less than 0. Zero slope. Here y does not change as x increases. X is increasing. Y is not increasing. So m is equal to 0. So it's going to be an exactly horizontal line. The slope of any horizontal line is 0. The line is neither going up nor coming down. It is exactly horizontal. An undefined slope. When the line is exactly vertical, an undefined slope. The line is exactly vertical. This one is an undefined slope. Exactly vertical. It does not have a defined slope. So it's actually like this. Anything divided by 0 is undefined. So we'll come to it on a later stage. Let's see. So to understand this, the equation remains sacrosanct. Y is equal to mx plus b. The vertical line is parallel to the x-axis of the coordinate system. All the points on the line will have the same x coordinate. So there is no change in the, if there is a vertical line, the x-axis doesn't change. So it's like remains the same. If it is 2, it will remain 2. If it is 3, it will remain 3. So if this is a vertical line, there is no change. A vertical line has got no slope. Or put one way, the vertical line, the slope is undefined. You do not know what is the slope. The equation here is x is equal to a. A is where the line crosses the x-axis or the x-intercept. We'll come to it, y and x-intercept. We know the y-intercept was b. This is the y-intercept. A is defined as the x-intercept, where the line crosses the x-axis, where x has got a value, y is equal to 0. Fair? So this is a vertical line. Now on a horizontal line, what is happening? Is parallel to the x-axis of the coordinate planes. All the points in the line have the same y coordinate. So the moment I do it like this y remains constant. So this is a horizontal line and this is a vertical line. So the slope is 0 here. There is no upward or downward movement. Y is equal to p. That means b, which is the y-intercept, is having a value y is equal to p. You may always say that the parallel lines have the same slope. So the equation of a line through a point P1, if this parallel to the line is this, then A is equal to A into x minus x1 plus B into y minus y1 is equal to 0. Though we do not come across this kind of a situation in GRE or GMAT, still for honors, for a betterment of our understanding. Now this rise and run thing, let's understand what is this. Let's take an example. So that makes it easy for us to understand this. Say y is equal to mx plus b. So if we write like something like this, 1 by 2x minus 2. If I write this, say this is an equation, then m is equal to 1 by 2, b is equal to 2 minus 2. So in this, let's see m, which is equal to 1 by 2, which we can always write as change in y-axis by change in x-axis. As we know, this is y2 minus y1 by x2 minus x1. So we know the change in the y-axis by change in the x-axis. So how much up by how much down? That's what it is. So we can always say this is how much up or down by how far right or left. This m can now be said as it equal to rise by run. How much it went up by how much it ran on left or right. So the slope is rise by run. So in this case, it is 1 unit up and 2 units to the right. So in an equation, by merely looking at this equation, if I plot it on a graph, this will become like this, that it will be 1 unit up and 2 units right, and it will be a positive slope. The slope will look something like this. If we just take an equation and try to define it, plot a graph here, it will go somewhat like this. For every unit up it is going, it will go 2 units to the right. If this is 1 and just a schematic diagram, if this is 2, it will meet here. So similarly, it will go up, up like this. Clear? So that explains rise and run. Now, if I uh, do a simple thing, say let's take another equation. Say y is equal to 3 by 2x or minus 3 by 2x, let's say, plus 4. Then it's m becomes minus 3 by 2, which means minus 3 down and 2 right. I think that explains. Minus 3 down and 2 right. Clear? So the rise and run will come and again. So that's going to be haunting kind of a thing. So it's going to bother us. So the slope m, let's recapitulate here. Slope m is equal to y2 minus y1. That means the rise by the run, y x2 minus x1. If slope is 1, the angle formed by the line is at 45 degrees. So if this slope is 1 in any equation, so y is equal to x plus b. That means m is 1, then this line will be at 45 degrees. Not necessarily like this. So given a point and a slope, the equation of the line can be found. The equation of the straight line that passes through point x1 and y1. Slope is this. Clear? This is our basic understanding. Now let's understand this intercept kind of a thing. What is intercept? Let's go by two intercepts. One is x-intercept. Another is the y-intercept. This is x-axis, where the line touches the x-axis. So it will become x somewhat value and 0 because y will be 0, or let's say y is equal to 0. Y-intercept will be where the line touches the y-axis. So x will become 0 and y will have some value. So x is equal to 0 here. This is the simple understanding. Now you can always tell me, where do these two lines, if I draw two lines on a coordinate plane and say the other line is like this, they interact here or they intercept here, they cross each other here. The point of interception, point of intersection. What is the point of interception? Let's draw two equations. Say y is equal to 4x minus 10 and say 2x plus 3y is equal to 26. Two equations, two different equations, which implies that if I put y here, 2x plus 3 into 4y minus 10 will become 26. One second, become 26. If we solve this, y is equal to 4. So if y is equal to 4, if we solve this, then x is equal to 4. If x is equal to 4, then y becomes equal to 6. Just a simple equation we can solve. So the point of intersection, the point I'm trying to make of intersection, or where the lines cross each other, these two lines will cross each other, is 4 and 6. So that gives us a slight of an understanding of what this is like. So just to draw it here, the point of intersection of the two lines, straight lines, there should be two straight lines, obviously, having, as we took an equation, the point of intersection of two non-parallel lines, obviously if they're parallel, they will never meet, can be found by the two lines having two different equations. So how to do it? We did it right now, having two equations, and then we substitute it and we could find the x and the y coordinate, and that's the place where they will intersect. If y is equal to this and y is equal to this, so obviously if we just replace the values, we will find. And this is the place where x will have a value and y will have a value. So this is the place where they are going to intersect. So we have been doing a conversion from algebra to coordinate geometry, or rather uh, plotting it on a coordinate plane, or vice versa. So if there are 2 points, now we are playing around with it. Using 2 points, the equation of a straight line passing through this point P1 is this, P2 is this. The equation of a straight line will take a form like this. Using 1 point and a slope, so obviously if I know 1 point, slope m is y minus y1 equal to m, is basically m is equal to y minus y1 by x minus x1. Clear? It's just we are playing around with the same kind of a thing. The equation of a straight line whose x and y intercepts are a and b is this, as we did previously also. X by a by y by b is equal to 1. Let's see. Find the equation of a straight line whose x-intercept is 5 and y is 2. Not to delve much, we'll have to find the equation of the line whose x-intercept is 5, means the line touches x-axis at 5. Y-intercept is 2, so it touches at y at 2. So we can substitute the value x by 5 plus y by 2 is equal to 1. So the equation will become 5y plus 2x minus 10 is equal to 0. This is the general form. If we put it on a slope intercept form, it will become y is equal to minus 2 by 5 x plus 2. This is the second form. This is the first form of the equation. This is the second form of the equation. Merely by knowing the intercepts, we can come back to the algebraic form of the same. Clear? So let's move on. For a perpendicular line, two lines having this equation, a1x plus b1y plus c1 is equal to 0 and a2x, etc., etc., are perpendicular if a1 a2 plus b1 b2 is equal to 0. If the x-intercepts and the y-intercepts add up to a summation of 0, then they are perpendicular to each other. So let's see how it happens. The equation of a line passing through the point this and perpendicular to line is this. So bx minus x1 minus a into y minus y1 is equal to 0. Just two equations here, this one and this one. Clean. Fair. With this understanding, let's see further. Same thing on a circle or a plane. We can, the same thing can happen. There is a circle drawn. So how do we do it? In a XY Cartesian coordinate system, the circle with the center AB, the center of the circle is AB, the radius is R, is set at all points XY. So XY will become, keep moving like this. So that becomes a circle. Such that obviously the distance R is actually, if I draw a triangle like this, the distance between this and this using the typical Pythagoras theorem is R square is equal to x minus a, and this is x, y minus b, then R square is equal to x minus a the whole square plus y minus b the whole square. Clear? Similarly, if the circle is centered at the origin, if this is the point, oh, this point is 0, 0. So our equation takes a different shape. X square plus y square is equal to R square. Clean? Now, circle is okay. Now let's see how a parabola will look like. A parabola is a graph associated with a quadratic function. So let's understand this kind of a graph will happen only when there is a quadratic function. So it will never, it will, the general standard form is y is equal to ax square plus bx plus c. Or in the function form, it will be ax square plus bx plus c. So if this is the form, then the graph will take a plunge like this or go outside or will form a mountain like this. Either it is a ball or a mountain where x is an independent variable, y is a dependent variable because y depends, whatever x is changing, y is a dependent variable, ABC are constants. If I look at a graph like this, an equation like this, and plot a graph, the larger the value of a, the larger the value of a, the steeper or thinner the parabola will be. So it will be like this. Since the value of y increases more quickly. So the larger the value, the larger will be the change here. So the value of y will quickly increase. If a is positive, the parabola opens upward like this. It's going to be a parabola which is like this if a is positive. If a is negative, the parabola opens downwards. So this will be like this. If I plot this with a positive a, it will become like this. If I plot this with a negative a, the parabola will be like this. Let's look at this part. That will make it easier. But let's understand this discriminant first. So we all know x1 and x2, the two values of x in a quadratic equation is equal to minus b minus root over b square minus 4ac by 2a. This is called as the discriminant. This much part is called as the discriminant, b square minus 4ac. But values of x and y are found by this equation. But if that is the case, they have got an impact on the graph we will plot. So if the value of a is positive and discriminant or this part is negative, that means b square minus 4ac is negative, then the graph will look something like this, positive and definite. If it is positive, if it's 0, then this will be indefinite. You can see the graph it dips further. If the value of A is negative, here it was positive, then the graph goes like this. If it is 0, it will touch here and this like this. So that's a basic look of the graph by looking at the equation. So the y-intercept here will be is equal to ax square plus bx plus c. Y-intercept is c. As y-intercept means value of y when x is 0. So if this becomes 0, then y becomes c. Clear? So folks, we got into something very basics of coordinate geometry. This much is required for as far as GRE and GMAT is concerned. When we'll take the sessions, we'll actually take a lot many questions which can bolster your understanding. Right, folks? Thank you.